Okay, I think we've got everyone here pretty much. So, you've done some pretty valuable stuff in the first couple of weeks. So you did your first PCB last week. If you haven't revisited that, I suggest probably one of the first things you want to do today is just make sure you can do what you did before. Okay? Now we're opening up the floor now because it's time to think about doing your assignment. Now if you look on the board, we're in the coursework section, and that's a circuit diagram of your metal detector, which I've put in here. Okay, you could make a printed circuit board of that. I think a couple of people did that last year, it worked quite well. You pass the, you're allowed to solder test as it were. So if you want to do some stuff on your metal detector, after I've finished boring you a bit, you can go in there and you can play, maybe do half hour, an hour on that, and then come back to your work. Okay, so a bit of fun at the same time as trying to deliver your assignment, yeah? I suspect most people are going to go in there and start doing some building. Shaheen and I will help you with any questions you've got. And hopefully, well, we might say a metal detector working today. It usually takes an hour and a half to do one properly. Okay, assignment one. So you're applying your skills, and I notice we've got some new faces in here. A bit difficult to go through the whole lot again, but if you look at some of those online videos and you talk to us, we'll try and bring you up to speed so that you're not disadvantaged. So assignment one is quite an interesting thing. It's called a photopopper. It's got lots of different names. Lots and lots of different names, but it's actually more a concept than anything else. Well, you can get off if you press really hard. Really hard. And what it involves is, it's kind of a classic resource problem. It's actually amazing how things in circuits actually compare to things in real life. You'd be really surprised how circuits can emulate very, very complex entities just with a few components. Now, a photopopper is, there's lots of different ways you can imagine it. Let's take a really simple one to start with. So, I want to buy a car. Okay. I haven't got enough money to buy that car, but I earn £10 a week. Okay? Very silly number, and it doesn't matter, the numbers aren't important, are they? So I earn £10 a week, but to buy that car, I need, so it costs £100. So what do? What's the obvious thing to do? Okay, we all know, don't we? It's called saving up for something. It's not the easiest thing in the world to do because you just work and you don't seem to get any gain from it. But all of a sudden, you've suddenly got enough, even though you didn't earn enough in a week to buy it. Yeah? That's the strategy that underpins it. So you imagine we now change that to an energy source. Now what could be an energy source? Lots of things. You could have piezoelectric, which is just a ceramic material, and you could put it in the bottom of your shoe. And the weight of you walking on that would generate a small electric current, and you could power something off it. But nothing very meaningful. You'd have a job to light an LED from it. You certainly wouldn't power a light bulb. You wouldn't power a microcontroller because there's not enough there. So let's assume we're just going to use a tiny, tiny solar panel. I'll get one out of the workshop in a minute, but they're usually not bigger than about that. So inside here, this is what we call indoor ambient. It's actually quite bright in here, but could you take a solar cell and run a small motor from it? In here? No, not a chance. On a bright sunny day, you might be able to go outside and point it directly at the sun, and a little pager motor, you know, think it goes in your phone. I can take a little pager motor and I can make that run outside in bright sunshine in the middle of the sun. Yeah, I could. But in this background light level, no, it wouldn't be any good. So what I can do is I can imagine these are the two wires coming out. What I could do is I could just say, well, let's do the same thing as the bank account. Let's put that onto a capacitor. Now, we've got some quite big capacitors down the back here. I think I've got some 2200 microfarads. Where are we? Just about as big as we go. 2200 microfarad. If you charge it up completely and you put that on a pager motor, that will go, and this is sort of scaled to real time, that will go, and that's all you'll get out of that capacitor from a pager motor. Not a lot, but the point is it can drive it, which is more than the solar panel can, because it can't do it. But hang on a minute, we're not out of the woods yet, because the solar panel, the capacitor starts off, obviously 0 volts here, 0 volts at the top. So your first charge takes a long time, because you've got to go from 0 up to your supply voltage, which on these are typically about 4 volts, 3.8, 4, so let's say 4 volts, something like that. So we charge up. So what do we want to do? We can put a voltmeter across it, measure it. Once it's got to 4 volts, disconnect it, connect it to the motor. We could do with a switch or something, couldn't we? Do it with a switch. And we have a kind of working circuit, but it'd be us that's pressing it. So that'd be a bit dull, wouldn't it? Because this is electronics, we want to do something clever that we don't have to intervene with. So that's what the photopopper circuit is about. It's really about this. This is taken as red. That's your driving unit, that's taken as red. It's this we're interested in, because we want to automatically trigger the discharge of that capacitor at the point when it's got its maximum energy in there. Okay? So, I've been playing about with these in a funny kind of way for completely different purposes, which is inventory control. And I call it beam casting.